In this lesson, we have two goals. One, to simplify radical expressions by combining like radicals and multiplying radical expressions. And number two, to simplify radical expressions by rationalizing the denominator using conjugates. Now, we've already talked about what radicals are and what their different components are. Today, we need to focus on what the difference is between a like radical and an unlike radical, because that's how we're going to combine them. We can combine like radicals in the same way that we can combine like terms in an algebraic equation. Like radicals have the same radicand. So 4 square root of 11 plus 12 square root of 11, both of these terms have 11 as the radicand here. Square root of 11 is attached to both of them. Unlike radicals are, for example, this situation where you have 9 square root of 4 minus 7 square root of 3. They have different radicands. They are unlike. They cannot be combined. So just like if we had 4x plus 3x, those can be combined. But if we had 3x plus 4y, those cannot be combined. So it's the same concept. When we are combining like radicals, we're really just using the distributive property. So you can see here that 6 square root 11 plus 9 square root 11 is really 6 times square root 11 plus 9 times square root 11. So we can actually rewrite that as 6 plus 9 times the square root of 11. And when we do that, we can very quickly see that we can combine our 9 and our 6 to give us 15 times the square root of 11. And since this doesn't simplify, it's a prime number, we're done. Let's look at another one. In this case, we have the square root of 3 minus 5 square root 3. We have the same radicand. Both have 3 as their radicand. In this case, we have to remember that there is an implied 1 right here. We already have a 1 outside that square root of 3, just like we have in x, we have an implied 1 out in front of it. So what we're going to do is use our distributive property, right? So we're going to have 1 minus 5 times the square root of 3. And when we do that, we simply subtract, so we get negative 4 times the square root of 3. And that's really all there is to it for these problems. Obviously, it's not usually going to be that easy. Sometimes we're going to need to do some simplifying first, in the same way that we did in the last section. So in this case, we see 5 square root of 3 minus the square root of 12. When we look at the square root of 12, we can see that that can be broken down into the square root of 4 times the square root of 3. So that what we wind up with is the square root of 4 is 2 times the square root of 3. And then we can finish writing this out again. 5 square root of 3 minus 2 square root of 3. Use our distributive property. 5 minus 2 times the square root of 3. And we'll get 3 square root of 3. So all we're doing is simplifying first and then doing, just like before, combining our like radicals. Here's a slightly more complex one. Once again, we've got 5 square root of 32 minus 4 square root of 18. And these two are not the same. They are unlike radicals. So we're going to try to find a way to simplify to get like radicals. So I've cleared out some space. And the first thing we're going to do is look for our factors of 32 and of 18. The factors of 18 are pretty easy. 1 and 18, 2 and 9, 3 and 6. And we're good. The factors of 32 are 1 and 32, 2 and 16, 4 and 8. I believe that's it. So what are our common factors? Can we find any perfect square factors that would help us out? In this case, we can see that 5 has a factor of 16 and 2, 16 and 2 here. So that will give us 5 times the square root of 16 times the square root of 2. And this will leave us with 4 times the square root of, well, we see another perfect factor here in 9. So we can do 4 times the square root of 9 times the square root of 2. Now this is nice because we can see that we're going to end up with a square root of 2 once we take care of our perfect squares. So let's go ahead and do that. We'll be left with 5 times the square root of 16, which is 4, times the square root of 2, minus 4 times the square root of 9, which is 3, times the square root of 2. And that's going to give us 20 square root 2 minus 12 square root 2. And now you can see we can combine. We've got like radicals here, 20 square root 2 minus 12 square root 2. We simply subtract the 20 and the 12, and we get 8 square root 2 as our final answer. You can see there are no more perfect squares of 2. we're done. Combining like radicals is fairly simple. Let's revisit multiplying radical expressions with a little bit more complicated expressions. What we're going to use is simply the distributive property when we see problems like this. You recognize this, hopefully. You'll see that if we were to replace this with things that weren't radicals, this would look exactly like a standard distributive property problem. And all we're going to do is exactly what we normally do. We're going to multiply over addition, right? We're going to multiply over addition. We're going to combine square root of 10 times square root of 6 first, so square root of 10 times square root of 6, and then we're going to add square root of 10 times 3. And this one's pretty easy. That's going to leave us with 3 square root of 10. That's pretty straightforward. And the square root of 10 times the square root of 6, using our multiplication property of square roots, is going to give us the square root of 60. Now, are we done? Unfortunately, no. This side over here is already taken care of. There are no perfect squares for 10. Do you think there are any perfect squares for 60? Thinking about it for a moment, we can recognize that 4 will go into 60. We would have the square root of 4 times what? The square root of 4 times the square root of 15 plus 3 square root 10. So we're just simplifying. And of course, the square root of 4 is just 2 times the square root of 15, which doesn't have any more perfect square factors, plus 3 times the square root of 10. And that is as simple as it gets, so we're done. Now the next problem will involve slightly more work, but it's not any more complicated. We're simply going to use the distributive property again. And if you look at this, you'll recognize that we're looking like something that we would use FOIL on, right? We got our first here, we've got our outside, we've got our inside, and we've got our last. So that's exactly what we're going to do. We're going to multiply our first, and then our outside, and then our inside, and then our last component. So let's get that done really fast. The square root of 6 times 4 square root of 3. So we're going to have 4, and then we'll multiply our roots together. That's going to give us square root of 18. Then the outside, square root of 6 times 3 square root 6. That is going to give us a positive 3. And then we'll have square root of 6 times the square root of 6, which is square root of 36. And then we'll do our inside, negative 2 square root 3, 4 square root 3. That's going to give us a negative. So we'll have negative 8, and that'll be the square root of 9 when we multiply square root 3 times square root 3. And finally, we'll be left with another negative, and we will have negative 2 times 3, which is negative 6, square root 18. Then all we have to do is go through and do a little bit of simplifying. So we can see that 4 square root 18 is the same as 4 times the square root of 9 times the square root of 2. And it's a perfect square factor, so we can simplify that. This is going to give us 3 times the square root of 36, which is obviously 6, minus 8 times the square root of 9, which is a perfect square, which is 3, minus 6 times the square root, once again, of 18, which is the square root of 9 times square root of 2. Let's go ahead and do all our simplifying again. 4 times the square root of 9, which is 3, so 4 times 3 times square root of 2. You don't have to write out each one of these steps every time. But I want to show you in this case. 8 times 3 is 24, minus 6 times the square root of 9, perfect square, that's 3, square root of 2. One more little step here. We'll get 12 square root of 2, 4 times 3 there, plus 18, minus 24, minus 18 square root of 2. Still not done. We've got to combine our like terms, right? So we can combine our like radicals here. 18 minus 24, that is going to give us a negative 6. So we'll have a negative 6 here. Negative 6, and then we can combine our 12 and our negative 18. That's going to give us a negative 6 times the square root of 2. So our final answer will be negative 6 square root 2 minus 6. That's it.